Are you ready to take your Hot Wheels car to the next level? Wave goodbye to your old toy car collecting dust on the shelf and get ready to transform it into a 1/64th scale model micro car that you can remotely control, all while experiencing the thrill of first-person driving with live FPV video feed. Imagine being inside the cockpit of your very own miniature drift car, controlling every move, feeling the rush, and living the excitement firsthand. Now it's not just a dream anymore, it's a reality, my friend. And in this video, I'll show you how you can do it. So grab your Hot Wheels car and let's hit the workbench. Before we dive into this exciting project, let's set the stage. This FPV RC car modification is intended for those of you who already have previous experience building, modifying, or controlling RC vehicles and a basic understanding of electronic components and Arduino boards. Just so you know, I won't dive into great detail on the technical aspects of this project, such as coding or the wiring of certain modules, as the free resource files I've left in the description below this video should give you what you need. Before we dive in further, here are the essential tools we'll need. A hot glue gun, multimeter, flush cutters, pliers, wire stripper, utility and craft knife, helping hands, soldering iron, drill machine, or a rotary tool with appropriate drill and cutting bits. Other materials and supplies for the car would include different kinds of tape, heat shrink tubing, metal strips, wire, tiny steel tubes, electrical wire, perf board, and the adhesives. Lastly, here's the electronic parts that will be going into the car. All of what was shown can be found listed in the description below with purchase links. For the Hot Wheels car itself, I chose the Porsche 993 GT2 sports car for its vibrant red paint job and wide body look. Its wide body and rather tall cabin area makes the car a great choice for converting into a remote controlled one, as it's got decent volume for packing all the electronics inside. Getting right to the disassembly of the car, let's drill away at the rivet looking standoffs that keep the base from coming loose. With it all disassembled, let's work on the car's base, removing the wheels and cutting away unnecessary plastic that would otherwise be in the way. Now there's enough space for the steering mechanism and the drive motor at the rear end. Hey makers, did you know you have a chance to win a giveaway here? Stay tuned for the giveaway announcement coming up later in this video. Focusing on installing parts, we have this tiny motor taken from an old 9-gram servo that will be used as the car's drive motor. We'll open it up and work on replacing the current shaft for one that's twice as long, turning it into a dual shafted motor. Putting it back together will require making a hole at the plastic commutator end where this shaft aligning ring sits. Next, we'll sand the modified motor and solder on one of these nickel strips that are found in laptop batteries or purchased for making DIY battery packs. Bending the strip of metal, we can now align the motor with where it should sit in the body shell, cut away excess metal, and glue it to the base. With some other 0.2mm nickel strips, let's make the clamp-shaped hinge pieces which will be holding the front wheels with their axles in place. On-sheet blueprints for every part that you need to cut and bend can be found linked in the description below for you to replicate. Then we'll free the wheels from their axles, using an end for each front wheel cut from one axle, forming a 90-degree bend once put through each wheel, in turn allowing us to glue short sections of 1.5mm metal tube up against the bent axles. Once dry, the wheels should still be able to spin. To strengthen the bond, let's also apply some epoxy. Cutting a couple of short pieces of 1.5mm wire, sliding them into the hinging tubes will allow us to clamp on the metal sheet hinging pieces we made just before. We can also solder them to make things more secure. Let's make sure the wire ends are bent up for the steering link, and then we'll focus on carving out enough plastic in the base to get the front wheels sticking out the right amount. Now the steering hinges holding the wheels can be superglued to the base. Looking at how they hinge, the steering part is already coming along nicely. After gluing on some supporting washers to the steering arms, we can get on to making the steering link out of some paperclip wire. It should end up having looped ends matching the distance of each steering arm and a notch pointing upwards with a gap between. Once linked as a part of the steering, the arms can be capped off with 2 wire rings soldered on top. With the steering system made and functioning, we can install the 1.5 gram Ultra Micro Digital Servo into place, linking to the steering mechanism through a bent piece of remaining Hot Wheels axle rod. This is then glued with the servo horn up top. Next up, let's solder and install the rest of the electronic parts. We'll achieve this with the TS101 soldering iron from Miniware, sponsors of today's video. The TS101 is for those of you who want a fast and efficient approach to working with electronics, as it heats up in a matter of seconds, prevents fire hazard with automatic cool down when not in use, and is portable for off-grid use since it can be run from a power bank too. As they say, you'll never regret investing in quality. The TS101 proves just that through being a long-lasting soldering iron just like the other models from Miniware that I've used. The TS101 could be yours today. Click the purchase link below to learn more about it. So we'll get right into it and start by soldering to prepare the car's battery, taking two 50 mAh cells in parallel and converting them into a 100 mAh battery pack. Then we're going to cut out some room for the battery's charging connector, which will face down. Drilling a couple of holes on the other side will allow us to place a switch to turn the car on or off. Now focusing more on modules, for the car's FPV camera we'll be using Seeed Studio's Shoutout ESP32 S3 Sense, a thumbnail-sized Arduino-compatible camera module sporting a 32-bit microprocessor with its main peripheral being the 2-megapixel camera. A really unique little device kitted out with Wi-Fi and Bluetooth for miniaturized and wearable applications. It even takes micro SD cards up to 32 GB to run video streaming applications such as the ESP32 MJPEG camera web server. You can order one of these today through the purchase link below. Giveaway time! Seeed Studio is giving away 5 of these Shoutout ESP32 S3 camera modules, and you have a great chance of winning one of these. All you gotta do is leave a comment about your unique project idea of what you'd make with the Shoutout camera board, and I'll be the one picking 5 lucky winners based on the ideas I liked the most. So go now, comment below, and I'll notify you if you've won by the closing date of September 21st. Good luck! Diving into the more detailed electronics of this car, we'll make a very simple MOSFET motor driver board. Other diagrams, including ones for the modules you see me make, can be found in the description. Soldering some thin wires to the Shoutout board, we'll hook up this radio communication module as the receiver. Then we will connect the newly made motor driver up to the Shoutout, taking up one of its I/O pins for the PWM varying signal, followed by the battery connecting to the Shoutout through the switch we installed earlier. Tutorial aside, this is not the wiring or module selection I actually ended up with, but merely a step in the process of figuring out which module I could get to work as a receiver for the car. On the computer, I first loaded on code to check that the ESP32 S3 camera module works and runs its camera web server as it should. If you want to set up your ESP32 camera board with the camera web server you just saw for this project, then I recommend you go check out a previous video of mine which discusses just how to do that. Save it to your watch later playlist, and let's keep going. I soon realized that the NRF24 transceiver module was not a fit for this project, as it took up way too many I/O pins on the Shoutout, resulting in a peripheral pin clash, not making it work with the radio communication at all. Couldn't get things working no matter what I did with combining both codes for control and the camera. So having to dig for solutions, I went on to trying to get a Bluetooth receiver module going with the Shoutout. First, I attempted to reprogram it with an Arduino, testing that certain commands worked as they should, but failed to link it to any other app than the one it was originally programmed to work with, not giving me car controls. So the second attempt at finding a working receiver really flopped. This made me later think, hang on, if I plan to have the FPV feed work based off Wi-Fi, why shouldn't the car's control work that way as well? So I just happened to bump into a code for a Wi-Fi web server controlled car on GitHub. Credits to code author Bryant Wong. A link to where you can download this code can be found in the description below. I very well knew it would be an arduous task to combine two codes on one ESP32 chip having two different web servers, so I got a better idea. I found this Wi-Fi microprocessor chip lying around from another project. Another thumbnail-sized board with an inbuilt antenna and at least 10 free I/O pins, which was just perfect. I got straight back to work, now programming this chip with the code I found to work, first prepping some jumper wires, then inserting everything on a breadboard with some transistors and a USB to serial converter, resulting in a programming circuit I came up with based on the info given on the chip's datasheet about its strapping pins for programming. So I successfully uploaded the code on the first try, then I took the included CSS code in the given data file for creating the web page with the control sliders and uploaded it as well to the board through the Arduino IDE Sketch Data Upload feature. Logged on to the newly created access point and typed the IP address into the web on my phone for the virtual control panel with the sliders. Having the car's motors hooked up to the ESP32 C3, I tested to see that it was receiving my input successfully. Since I wanted to have bidirectional drive control over the car, I got onto designing an H-bridge transistor motor driver first on a breadboard and then on a perforated board with tinier surface-mounted components. A diagram for this circuit can also be found in the description. After sizing it down, I gave it some wires and hooked it up to the ESP32 C3. During testing, the motor spun both ways, but at surprisingly low torque for some reason, an issue I managed to deal with later in the video. The car's steering here seems to work until it randomly gets stuck due to the servo horn bending backwards, in turn needing to always be pushed down, which isn't good. So let's combat this issue by bending then soldering a fixed section of paperclip wire going over the servo arm. This will keep it pushed down during movement. Next up, installing the battery. We'll secure it in between the servo and drive motor, then connect its wires in parallel to the charging connector and the positive line through a switch. Time to hook up the module, which will be the car's FPV camera. We'll solder the battery wires to the board's dedicated battery input solder pads. Once secured, we can even give the car a pair of 3mm LEDs as the headlights. These will be powered and toggled through one of the Shout's I/O pins. And the H-bridge motor driver gets installed right up front, making the best use of space. According to the diagram, we need to solder on 2 capacitors and a resistor to this ESP32 chip. Not those big ones, but these tiny surface mount versions of the components. First goes the pull-up resistor to enable the chip, then a capacitor to stabilize power at the enable pin, and lastly another decoupling capacitor of a higher capacitance to stabilize the ESP32's power supply from any ripples. To keep things compact so the chip can fit inside the car, we'll have to trim off the onboard antenna for a wire antenna, and then we'll solder a strip of metal which will connect it to the rest of the car. One mistake I made here was cutting off too much of the PCB antenna that I nearly lost the antenna track leading into the chip. One obstacle after another, and soldering on stiff wire was what made it worse, losing more of the track. Fortunately, soldering some thin wire strands was what did the trick. I secured this connection really well with some epoxy and got on to soldering on some antenna wire. Figuring out how the ESP32 chip is going to sit at the back of the car, we can trim excess metal strip and solder it to the drive motor. Bending and positioning it into place, the ESP32C3 should sit with a slight decline over the motor. Onto the wiring, let's start by connecting up the motor driver with its jungle of wires. Then we'll hook up the servo motor and finish up with any remaining power connections. Here's a custom charger I put together. Using one of the blue 1-cell charging boards, we can charge up the car's battery in about an hour. While the car is charging, let's focus more on the car's metallic body shell, get rid of those binding posts, and perhaps even widen the headlight holes. If you have a rotary cutting tool, this will probably go easier, but since I only have a drill machine, I got crafty and made a custom cutting bit out of a larger grinding disc. Oops, my grinding bit couldn't make it through the second post, so I made another one, this time a little larger. With the posts mostly gone, we can grind down excess metal and smoothen the inside with a sanding bit. For the FPV camera to poke out, we gotta drill a reasonably sized hole, basically giving the car a sunroof. Since the H-bridge driver didn't deliver the necessary power at such a low input voltage, I decided to swap it out for what worked best, the single transistor motor driver that we made earlier. This means the car will only be able to drive in the forward direction. Turning on the car and connecting to its web server, we can see that the motor starts but doesn't want to stop. This is due to the programming that went into running it with the H-bridge bidirectional driver. So we'll quickly reprogram the chip by reconnecting it to the programmer circuit I made earlier, and change the following values in the code to make the motor go from 0 to full speed and nothing else. As seen in the serial monitor, it is now doing just that. Great. We can now unplug the car from the programming circuit and test it out on its own. The drive motor keeps getting stuck from the friction the dual-sided shaft produces. Maybe some petroleum jelly will do the trick. That's better. To smoothen the motor's power draw, we'll even solder on a small ceramic capacitor at its terminals. Finally, it is time to throw on some wheels on this puppy and secure down any loose or dangling parts with some glue. To cover up the windshield and windows, let's use some thin black cardboard and cut it into shape so it fits inside the car. We'll also take some preventative measures against short-circuiting by adding a heat-shrunken tube piece over the ESP32 chip at the back. The FPV camera needs its own antenna too, so let's hook up this cut-down clip-on antenna poking out front. Out of hot glue, we can even cut some tiny pieces as the headlight lenses or covers going in front of where the LEDs will sit. For the headlights, let's instead use these powerful little 3mm 1W surface mount LEDs with a current limiting resistor not to draw so much power. Let's also give it a connector on board the car to plug into, so removing the shell is made easier. After gluing in the headlights, we can also prevent any light from scattering inside by laying on some aluminum foil pieces up against them. With the metal body shell on, we're nearly done. We just need a tiny piece of foam to support the FPV camera up top. Additionally, we'll add some electrical tape strips on the sides of the base so there's a much tighter fit, holding the car in one piece. Whoa, that was quite the journey from having what was a regular Hot Wheels car to now a 1/64 scale FPV RC car. The car weighs in at only 45 grams, light enough to pick up some speed. Quick shout out to a subscriber, Rimbang, who guessed this exact project back when I posted a teaser photo on the community tab showing just a few parts. Good guess, buddy. What I'll show next is how you launch two of the car's web servers on separate devices, one for controlling its movement, the other for viewing live camera feeds straight from a set of goggles. We'll first turn on the car and connect to the car control access point in the network settings of one device and the ESP32 MJPEG access point on the other. Then we can look up the same IP address on both devices, leading us to the two different web servers corresponding to the network we connected them to. The virtual control panel allows you to steer the car left or right and drive the car only forward, while in the phone up top you can press the web server start stream button to start the live video feed. More on this web server is covered in my full ESP32 cam video guide linked below. To make things more FPV-like, we'll use one of these old phone VR goggles and use them for viewing the split screen FPV feed from one of the phones. I only managed to split screen the video feed to one side as these are intended to be multitasking windows. Though I did try to use this app called Native SBS, which allows you to toggle on split screen mode for VR, so anything you do on your device is happening on two windows simultaneously. But the catch is that your device needs to be rooted in order to use it. I tried rooting the only old Android I had at home. I was successful in doing so, but realized that my phone had to be Android 6.0 or higher to make it work with the app. If you're willing to take the risk, I recommend using SBS for the best FPV experience. For now, I'll stick to looking at the feed through one eye as the half split effect appears nearly the same. Now we're ready for some FPV RC action. In the camera web server is where the headlights are toggled either on high beam, low beam, or completely off. To step things up a notch on dry testing the thing, I've come up with an obstacle course the car needs to pass. Zigzagging its way through numerous objects and returning it to myself by looping all the way around it all. The car's control range comes in at around 10 to 20 meters with its little antenna, good enough for controlling it within any room at home. And to view the recorded FPV feed, you simply pull out the micro SD card at the back of the car and shove it into your PC for offline viewing. Despite not managing to make the micro car a bidirectional motor driver, nor giving the car a removable battery to get back to having fun quicker, I still think I made an interesting breakthrough by being able to fit so much into a Hot Wheels car and still making it work. If you dare to take on this project, you could work on improving the car on those 2 points or even adding more to it. But if you're on a tighter budget and you still want to make your first RC car, then check out my previous video on how you can make a remote controlled car with steering all out of PVC. See you there!